Welcome to Feature Fridays. My name is Guy Bartram. I'm Director of Product Marketing for our cloud providers in VMware. And I'm joined today by Manish and Rohan. Welcome, guys. Let's start with a round of intros. So Manish, why don't you go first?
Thanks, guys. So my name is Manish Arora. I'm part of the cloud service provider business unit. I run the product management team that covers sovereign clouds. Mm-hmm. You may have heard of it. App modernization, and the ecosystem portfolio for our Cloud Director platform. So we have a broad chatter, and happy to be here, Guy. Thanks for coordinating this session.
No worries. And you got your hands full, man. So look forward to hearing about what's happening in app modernization, which we're going to be talking about today. So Rohan, please tell us who you are and what you do.
App modernization is a great topic, though. So Rohan Mukesh, Senior Staff Solutions Architect. I'm based out of Dallas, Texas, part of the MapBU business unit, or MapBG as we call now. So what I do, my role is I help the partners, cloud providers in their journey of app modernization and help them to adopt Kubernetes as a service, and then go up the stack around data solutions and some of the centralized way of managing the clusters using TMC and TSM is my role.
Excellent. Yeah, thanks, Rohan. And that's really good kind of lead into what we're going to talk about today, which is a new auto-scaling capability with CSE and TKG. And this portfolio has come a long way now. I mean, it's really starting to get quite big, quite fully comprehensive, and providing a lot of value. And this is why we're having this Feature Friday today. So Manish, I know you got some slides. Should we dive straight into those?
Yeah.
Okay.
Let's do it.
Let's go for it.
Yeah. So if you can, we put together some agenda here. So the main focus area for today's session is going to be how we can achieve cluster auto-scaling capability in our multi-tenant Kubernetes infrastructure service offering. So Rohan's got some good content and a demo to basically cover that. But I thought maybe we can take an opportunity here to our listeners and viewers to basically provide them a very quick overview of the overall app modernization portfolio that we are pushing in the market for our service provider industry. So if you can go to the next slide, Guy.
Yep.
Yeah. So as you can see here, we have a broad-based, I would say broad-based services and solutions as part of what we call as a developer-ready cloud, which is basically, part of the overall, VMware cloud service provider app modernization portfolio. So the teams have been working quite diligently for many years, building these capabilities and solution offerings that can help our service providers, to build a developer-ready cloud. As the industry is moving into more into AI and ML kind of workloads, big data transactions. And the lot of data center infrastructure revitalization is happening with many of the chip vendors are coming up with the advanced capabilities. Yeah, so just from left to right, we got App Launchpad, which is really simplifying your app deployment on the Cloud Director platform. There's a VRA, that's a vRealize automation from VMware integration with our Cloud Director to provide, operations and monitoring and those kind of capabilities. And then, Terraform to really automate our lifecycle provisioning with the VCD. And this has had, close to 4 million downloads.
Wow.
The application catalog is an enterprise grade artifacts for our for the large providers, we're basically, want to make sure that, security and compliance are addressed. Then, getting into the container service extension, this is basically the core component that enables, running container workloads in a multi-tenant, multi-cluster environment using Cloud Director. We'll touch base a little bit more on that. And, data solutions extension is another very strategic offering from the service provider business unit. As you can see, with AI becoming mainstream, we're seeing, huge surge in data lakes and data warehouses and a lot of, data services around AI and ML. So we're actually, doubling down on adding, a lot of these modern data services as part of the data solution extension portfolio for our service providers to better compete with the hyperscaler offerings. Content Hub is another very important offering that is going to be coming out soon, providing a unified way of managing all the different, the images, right? The cluster images or the container, application images and the catalogs as part of the Cloud Director deployment. And then, then the last one is still kind of early in the stage where we're basically looking to collaborate with NVIDIA on the large language model as a service offering, and this is getting more into generative AI and all the good stuff that's started to show up in the industry in last 9 to 12 months, right? Yeah. So again, very broad portfolio, and all these I would say, like, traditionally our service providers, right? They have invested heavily in the VMware technologies. They have partnered with us for many years, building an infrastructure as a service stack, using Cloud Director and our SDDC. Now, VMware and VCPP and the BU, basically we're very well positioned to offer the developer-ready add-on services that can overlay onto their existing investments they have made on the IaaS stack to really move the needle in terms of getting from IaaS to being maybe platform as a service provider. So a very exciting guy. I think this is and there's a lot we have done, but I think there's a lot more to do here.
Yeah, I mean, it's pretty cool when you look at it, right? I mean, like you said, it's a complete spectrum of delivering apps, automating with infrastructure as code, to making Kubernetes or Tanzu Kubernetes Grid a first-class citizen in VCD, to now full data solutions lifecycle management, and of course the trending addressing the trend of large language models and AI and ML, which is, if you look at what Cloud Director did before and now what it's doing now, you've got this whole new layer of capability that our cloud providers can take and monetize and provide services on and manage services on. So it's a fantastic kind of base to build from. All right,
so going into the next slide, I think we want to mainly focus on multi-tenant Kubernetes infrastructure as a service offering with our Tanzu and VCD and container service extension components, right? So really getting into the different phases of this overall journey. Like I said, we have a very compelling story, and we have real innovation happening and real offerings to back that narrative, that agenda that we're pushing in the market, right? So the phase one is really talking about deploying the multi-tenant Kubernetes infrastructure as a service, on top of the foundational IaaS stack from VMware, right? And that involves basically the Tanzu Kubernetes grid that also involve, running container service extension, which is basically you can have, tenant container workloads run in a multi-tenant environment with our VCD deployments. And, it's very important to have the foundational capability seeded correctly so that, you can basically continue with the phase 2 and the phase 3 of the overall journey here to get to the fully developer ready cloud, right? And the phase 2 is where, we're basically gonna, we already have Cloud Director as our unified management platform for the infrastructure as a service stack for the service providers. Now for Kubernetes infrastructure as service, we want to provide a similar centralized management platform, which is going to be our Tanzu Mission Control, and that's coming out soon. So we'll have that, overlay into our multi-tenant Kubernetes as service to provide, centrally managed multi and IT policies and things like that. And then, we'll also add in the ARIA business insights, along with that to get, all the metrics and the traces and whatnot, right? So that's kind of, the phase 2 where, phase 1 is just running the clusters in a multi-tenant environment with all the, foundational capabilities around, what we're going to talk today is autoscaling and multi-AZ and the read-write many, and a lot of the backup and the restore and the LCM around the Kubernetes operation. Then phase 2 is managing those clusters, managing the policies, right? Managing this, the growing multi-cluster environment that you would have your tenant workloads gonna be running, right? And then getting into the phase 3 is where, you see the honeypot, right, at the end of the tunnel, or the really getting into, developer ready data services, right? Every organization, every enterprise need data, and, the AI and ML surge in the market, in the industry, is basically a testimony on, how critical these data services gonna be for our service providers to really build a developer ready cloud, right? So we have the, we already have a data solutions that you can deploy, MySQL and Postgres on the Kubernetes operator. You can deploy, message bus as a service using RabbitMQ architecture. And we're also adding, very soon, NoSQL as a service, leveraging the MongoDB architecture stack, to really basically get into the big data, enabling big data AI ML kind of workloads. And then, and that's just the work is getting started there, right? I mean, we're looking to see if we can integrate, our Tanzu application platform into the Tanzu Mission Control, so that, developers can basically run their source code and don't need to worry about all the different applications and other infrastructure requirements. And then, continue to add more and more data services, right? Greenplum, right? Data warehouse as a service, seeing a lot of activity and demand there. So we're going to have the extension for our Greenplum, VMware Greenplum offering as part of the Cloud Director. Service providers really love the economics that we offer them, right? As part of our VC's PP program, which is, on-demand consumption model. And really want to have that self-serve experience, public cloud-like experience, when it comes to data services, so that they can basically, let their tenants know that they are, at par or better with the hyperscaler services or the offerings or capabilities. Again, very compelling story overall. And just wanted to, kind of give a very 50,000 foot overview on these things. Of course, each of these offerings have multiple teams working on it, a lot of support, go-to-market, enablement happening. So, happy to have discussions on those individual offerings in different sessions. But I think today the most important thing that we want to focus is on our, Kubernetes infrastructure as a service offering with VCD, CSC, and the Tanzu services. And as part of the container service extension stack, right? When you're deploying these, Kubernetes clusters or the TKG clusters, you would want to be able to, manage your container workloads efficiently and effectively, right, with the auto scaling capabilities. So I have here Rohan, who's going to take us through just a quick overview on the CSC, and then, we'll do a deep dive on the auto scaling.
Just one thing before we move on, Rohan, to your slot. Got to have my say here. Sorry, man. So one thing that's, I think, kind of missing from this diagram is when you're talking about developers, we're all thinking kind of application development, but there's also another side to developers that isn't mentioned here, and that's like the data scientist side.
Yeah.
And with the functionality we've got with NVIDIA GPU and the multi-tenanted vGPU that we can deliver with App Launchpad, delivering either the VMware Marketplace data science applications or using the NVIDIA, you have to be a member of their partner program to pull down those supported enterprise applications. There's a whole world of new offering to a new kind of tier of developer, and that is the data scientist, which is something that it's a gray world for me. I don't understand data science at all, but I know this is a very kind of interesting area to customers and providers as they look at their AI and ML kind of programming.
Yeah, so that's a great point, Guy. I think we have a broad-based, ecosystem partners that are helping us with some of the combining their data lake solutions with our VMware Greenplum data warehouses to build the next generation, data lakehouse architecture that can basically, help our data scientists to do real-time data analytics, right? So that's a really good point there. So.
Okay,
Rohan, should we proceed with you, or did you want to have your say as well on that one?
No, I think Manish, rightly so, he pointed out about Greenplum, because there are few partners that currently I'm working with on Greenplum where there is a huge interest in data science, analytics, utilizing the machine learning, GPU-based workloads, right? So Greenplum slowly, and I think the engineering right now is working to integrate Greenplum in the DS extension as well. So hopefully in few months of time, that will be a huge win from the VCD point of view as well.
Definitely. So if you're a service provider out there, you can start having those conversations as well. The sky's definitely not the limit.
Yes.
All right, over to you, Rohan.
Yeah, sounds good. So, on this slide, we just wanted to talk about the CACVCD and CAC4, the improvements which were made in CAC4. The first improvement which was made was the multi-control plane TKG. So now when the TKG clusters are being spun up, then you get the ability to have multi-control planes and from the providers and point of view. And if you think about the CAC and all of the enhancements which were done in CAC can be configured highly available, which means that you can concurrently deploy multiple CAC VApps to provide the support of multiple concurrent clusters from the tenant's perspective. So that's on the CAC part. Now, the CAC and the CAPVCD in general comes with an improved architecture where CAPVCD has been enhanced, which means that the clusters which gets created from the tenant perspective, they are all called as self-managing clusters. And when we say self-managing clusters, it's the entire life cycle of that cluster is being managed by the tenant themselves, and there is no say in a way from the provider, only to the point where CAC helps in the creation and the deletion of those clusters. And then, we rightly so talked about the GPU workloads where the CAC4 does have the option to enable the GPU in the worker node pools, so that if there are machine learning workloads, then they get the support for the GPU in the worker node pools as well. And in the end, the another enhancement which has been done in the CAC is to have this syslog forwarding, global proxy. So now the providers can really think about how can they forward this syslog that they have on the machines so as to visualize the logs much more easily. So these were some of the enhancements which were done. And now from the perspective of CAC, since CAC and CAPVCD has been improved significantly, we can now look into whether CAPVCD and how does CAPVCD and Cluster Autoscaler, which is the community-driven autoscaling provided by Kubernetes by themselves, does the community-driven autoscaler works with CAPVCD? That's the session I'm going to unfold. So, Guy, you can go to the next slide.
Just one thing I would like to add it in the previous slide, Rohan, if you don't mind, is really, like you mentioned, we break away with our CSC 3.x architecture, and we came out with a completely new architecture that's really targeted for our service provider community, right? I mean, things like self-managing cluster is basically goes to the core of, be able to do that self-serve for our providers, where they have to worry about, less things in their infrastructure when they're managing, Kubernetes infrastructure on top of their IaaS stack, right? So reducing complexity, adding a lot of automation, life cycle management is really what is hard MVP for us going forward, right? Because we want to make sure that our service provider continue to expand these offerings that they have for their tenants, but at the same time they can able to be able to manage them seamlessly in a manner that they have done on some of the previous offerings, right? So adding more offering doesn't necessarily increase more work on their end. It just kind of maintain the same kind of automated experience that they have been enjoying, with the cloud director having all these different data services and solutions, right? So just wanted to highlight that fact that, that innovation from 3x to 4x is really, goes to the core of, how we are kind of, expanding on our, portfolio for app modernization. Yeah.
Absolutely. CSC4 is a game changer, definitely.
Yes.
Exactly. Yeah. And just to segue onto the cluster autoscaler, what is cluster autoscaler? It is a community-driven project, and it is natively supported also within CAPVCD and the CSC part of the TKG. So what the cluster autoscaler does is, its job is basically to automatically add or remove nodes in a cluster based on the resource request from the pods, which means that if I have a cluster and that cluster has one worker node, which has a CPU of, let's say, 2 CPU and maybe 4 GB of RAM. But what I do is that I deploy multiple pods, and then those pods are requires the resources which the current worker node cannot help. Then what will happen is the cluster autoscaler then helps in this process and tries to scale into a new node so that the pod can be scheduled on the new node accordingly. One of the things that cluster autoscaler doesn't do, it doesn't directly measure the CPU and memory usage values to make a scaling decision. What it does is basically it looks into that, hey, the pod is requesting certain resources and the current worker node pool or the cluster doesn't have that enough resources. So let me go and scale it to a new node so that the pods can be scheduled. And the same thing, if you click on next, then you will see that, let's take an example over here. I create a cluster, and then what I do is in that cluster, I have one control plane node, but specifically I have one worker node, and that worker node, the way it has is, let's say it has 2 vCPUs and 4 GB of the memory. Then if you click on next, then you will realize that what drives these worker node and the cluster resources is basically the applications. And when we deploy applications into the worker node, these are basically the pods. Now, what will happen is if I have multiple pods, then those multiple pods can either be scheduled based on the current cluster resource, or if the pod requests a resource where the worker node cannot adhere to those resources, then what will happen is the responsibility lies within the cluster autoscaler, that the cluster autoscaler will listen to the worker node, and then the cluster autoscaler will scale a new worker node where the same pod n will basically get scheduled. So that's a bit of an overview of a cluster autoscaler. In the next slide, what you will actually look into is how does the scale up operation works. So basically, when a new pod requests are pending, the cluster autoscaler kicks in. What it does is it basically instructs the cloud director to instantiate the new VMs. And while the cloud director is instantiating the new VM, what happens behind the scenes is the Kubernetes keeps on listening to that new VM. And as soon as the VM gets instantiated with the adequate resources in terms of the CPU and memory, then the Kubernetes new node gets attached to that VM, and that gets reflected into the kube config, which means that now the new node of the Kubernetes basically is in a ready state, and which means that the pending pods can be scheduled into the new node. That's how the entire process of scheduling the pod, which doesn't have enough resources in the cluster, works in case of Cluster Autoscaler.
Yeah. So Rohan, I think it might be a good idea for our listeners here to, I know that the methodology that you have explained is basically horizontal autoscaling, right? And there is also a concept in the world of Kubernetes around, vertical autoscaling. So we just wanted to make sure that, if you can, help everyone understand, that, what's the difference and
yeah, I'll get there. Okay. So Manish, in the next few slides, what you will see is that this cluster autoscaler, the job of this is basically to autoscale the new nodes based on the pending schedule. There is also a concept of horizontal pod autoscaler, and then vertical scaling, as you just rightly mentioned, right? So we'll come to that in the end. So before we go, what I wanted to also talk about is CAPVCD and autoscaling. So how does the current cluster API and the cluster autoscaler work together? Basically, the CAPVCD, which is also called the cluster API for VCD, what it does is it works on the machine deployments or machine sets or machines, which means these are, when you create a Kubernetes cluster or you have a control plane and a worker node, these worker nodes gets translated into a machine deployment. And that is something that you will see in the demo. So the cluster autoscaler is actually looking at the machine deployment and the machine sets. So if there is a change that is required in the machine deployment, cluster autoscaler actually picks that change and then acts accordingly. So that's the relation between how the cluster autoscaler and CAPVCD works together. So some of the design considerations, which is important for the viewers here, is if the user is managing the worker node for a specific worker node pool using cluster autoscaler, then they should reframe from managing the worker node pool using the VCD UI or the API to scale the worker node pool. The point over here is, since what we are trying to demo here is the community-driven cluster autoscaler is currently being supported by CSC or VCD UI. The actual work of getting the UI integrated with the autoscaler is something that the engineering will do later. So once that happens, then just something that the viewer should take into consideration is they will not be able to manage the life cycle of the worker node through the UI if they are managing the life cycle of the worker node through the cluster autoscaler.
And Rohan, I assume there's specific VCD allocation models that must be used for this pool to enable it to kind of scale out into spare resources. Is there any policy to restrict what can be done?
No, there is no such. So the way it works out, Guy, is when you create the cluster, then what you say, I want to create a worker node pool of TKG size small or a TKG small size medium. So that size is being kept into consideration by the cluster autoscaler. So as soon as the pod goes into the pending state, then the autoscaler then looks into the current machine deployment, which is the current worker node pool size, and then it scales the new VM of the same size. So that's how it actually does the mapping of what is present today and what it needs so that it can scale to map the pod to be scheduled.
And what's the best kind of allocation model to make sure that VCD does have the available resources for you to use?
I think it depends on the type of the cluster that is being created by the user. So let's say if I have 200 applications, then to adhere to those 200 applications, I would definitely create a TKG large or an extra large cluster. And then do we have those clusters being spread out? Do we have multiple worker node pools created in that particular cluster is something that somebody should take into consideration as well. Like, for example, when you create the cluster, then you get an option, hey, you can create 5 worker nodes in a pool with TKG small, and you can create 5 worker nodes in a worker node pool with TKG large. So those options are there. So in one cluster, when you create those multiple different set of node pools, you can actually adhere to the type of the applications that you have. So again, it boils down to the type of application and the resource requirement.
Yeah, got it. Okay.
Awesome. So how does the cluster autoscaler gets deployed today? This is the YAML file that you see in the right-hand side. It is basically a CRD or a resource definition or a deployment YAML file. Now, the interesting aspect of that YAML file is if you go below, then you will see there is a command, and that command is /cluster autoscaler -v is equal to 4, and some of those parameters which are being passed. Now, what is this? What are these commands, right? So this is the command when this cluster autoscaler gets deployed in the cluster, then through the command, there is a pod that gets created, and that pod is basically a cluster autoscaler. And beneath the scenes of that pod, what happens is there is this command that is running. So the cluster autoscaler is actually running in that particular pod, waiting to listen to a particular worker node. And where is that part where you would like to listen? So if you see, there is third last parameter which says node group auto discovery is equal to cluster API : namespace is equal to Kubernetes 01.-ns. Now, I have specifically mentioned namespace is equal to Kubernetes 01.-ns. What it means is the cluster autoscaler will try to discover where is my worker node pool. And how do I discover my worker node pool? Is by providing the namespace over here as the Kubernetes 01, using which the cluster autoscaler would determine that, hey, this is the worker node pool I should listen to, and I should make the changes and add the VMs and scale the VMs for especially this particular worker node pool.
Hey, Rohan, just a quick question. How does it monitor the resources available to the worker node pool? Where's it getting that information from?
So it gets the information directly from the machine deployment.
Okay.
So as soon as it discovers the worker node, that worker node is nothing but a machine deployment, and you have all of the information in the machine deployment. So I'll show you once we get to the machine deployment.
Okay. I'm just wondering how that reaches the threshold to know that it needs to deploy another workload.
Yeah, sounds good. So I'll definitely try to show you in the demo.
Okay.
The next part is where how do we enable the components for autoscaling? Like components in this case is basically the worker nodes. Now, there are 2 important annotations that needs to be defined within the worker node pool. Now, these 2 annotations that you see over here highlighted in blue is cluster API autoscaler node group min size and node group max size. The node group min size specifies the minimum number of nodes for the associated resource group. The autoscaler will not scale the group below this number. And so one of the things is the cluster of API provider will not scale it down to whatever that number is, which we specify. So, and then the second parameter is node group max size. It specifies the maximum number of nodes for the associated resource group. The autoscaler will not scale the group above this number.
This is what I was getting at earlier. This is like the policy. This is like,
exactly.
Right, you got this much room to stretch out and you mustn't go lower than this room. Yeah.
And you know, the beauty of these is you need to add these annotations into the machine deployments. And once you add these annotations in the machine deployments, the cluster autoscaler, which is running with that command you saw in the previous deck, that will discover these 2 annotations. Yeah. That's how cluster autoscaler works. So, okay. Yeah. Now, a bit of word on the horizontal pod autoscaling, HPA for short. The responsibility of horizontal pod autoscaling is to update a particular workload resource. It can be a deployment pod, stateful set, with the aim of automatically scaling the workload to match demand. So demand meaning, if I can say I have an application which is running, but let's say during peak time, let's take an example of Best Buys or any retail store. When we have Thanksgiving, then that's the peak time for them. And if an application or a pod is deployed on the cluster, what we want to say is, hey, create the horizontal pod autoscaling rule so that if my CPU threshold goes above 50%, at any given point of time, and scale my pods. And I can provide my minimum pod and maximum pod as well, in terms of the parameters. So that's a bit around horizontal pod autoscaling. It is different than cluster autoscaler. Cluster autoscaler responsibility is to scale the nodes, while horizontal pod autoscaling, what it does is it takes care of it looks into the CPU usage, and then based on the traffic, it tries to scale the number of the pods. The reason why I mentioned horizontal pod autoscaling is because in the demo, this is something I will start with, and then you will see that how I segue into the cluster autoscaling, because I want to take into consideration that we are really talking about app modernization. So when we get into the applications, it's the application where we start with, and then the cluster autoscaler basically scales the nodes to cater to the applications.
Yeah.
So,
and it goes the other way around also, right, Rohan? So when you don't have Black Friday or things like this, so you can basically lower the count so that you can manage your cost of Kubernetes clusters in this highly multi-tenant multi-cluster environment, because you would want to be able to automatically tune in, tune out, right, based on the on your business.
Great point, Manish. Great point. The reason why I would say it's a great point is because the both horizontal pod autoscaling and cluster autoscaler, they not only work on scaling up, but they do work on scaling down as well. So if now in case of the Best Buy, where we don't need those enough resources, the pods will automatically scale down depending on the traffic based on the time which has been set, and the nodes will automatically scale down as well.
And for a service provider, it will help manage their consumption on a monthly or whatever, right, a yearly basis,
right.
So that they can keep the cost low.
Right. So, and now in this particular slide, what we are trying to show is kind of a recipe of how to deploy the cluster autoscaling, and then also from the application point of view, how do you trigger the cluster autoscaling? So the first step would be to deploy the cluster autoscaler as a deployment in Kubernetes. Then the second step would be to edit the machine deployment of the worker node pool. It can be done via API, the VCD RDEs that we have today. You can either use that using Postman, or you can directly go to the command line and say, I want to do kubectl edit machine deployment, and then I can add those two annotations, the annotations about the min size and the max size for the group. As soon as you add that, the cluster autoscaler will discover this worker node. Now, the third aspect of that is to really test everything out. You can deploy an application or a pod. You can configure the horizontal pod autoscaling for the application to scale based on the CPU. You can increase the load on the application using something like a load generator. The horizontal pod autoscaling will scale the pods, but what will happen at this stage is some of the pods will go into a pending state. And the reason why those pods will go into the pending state is because the nodes will not have enough resources to cater for those pods. And then the cluster autoscaler will then kick in. It will then scale the worker nodes scale the worker nodes, and a new VM will get instantiated into VCD. The new node gets instantiated, becomes into a ready state. The pod then gets scheduled in the node. That's basically a high-level overview and kind of in a recipe, if you will, for autoscaling. So while we were going through the recipe for cluster autoscaling, I've jotted down a few points that we went through. So the first step is to deploy the cluster autoscaler as a deployment. Now, when we go to the deployment, so here is my lab. Hope you are able to look at, able to see the lab. In this lab, the first thing I'm going to show you is my tenant. And this tenant is, I've got like 3 Kubernetes clusters already created. You can see by the name of Kubernetes 01, Kubernetes 02, and TK8S. Now, what we are going to do is, the plan is to deploy the cluster autoscaler and the horizontal pod autoscaler in this particular cluster. And I will try to show how the cluster autoscaler actually scales the nodes and the VMs. So if I go into the data centers and let's go inside the VMware cloud, then you would see over here is, let's go, it takes a second to pop up. So now if I click on the VApp and it's loading. So finally, right now, what we have over here is TK8S control plane node pool and a TK8S worker node pool 1. So these are the 2 nodes that we have. So now let's go into the command line and let me clear my console and let's do a kubectl get nodes. The first thing that you will see is the 2 nodes that you just saw in the UI. And then the next step is to deploy the cluster autoscaler. So in my current environment in the nodes, I already have a cluster autoscaler deployed. So let me show you the deployment for the cluster autoscaler. And this cluster autoscaler is actually deployed in the namespace kube system, which is the Kubernetes namespace where all of the system pods are running. So as you can see over here, one of the deployments over here is cluster autoscaler. So now let me edit the cluster autoscaler deployment so that we can look into the commands which are running in this particular deployment. So -n cube system. So now hopefully I will get the deployment pop up in a moment. And now as you can see, so the most important aspect while we were in the presentation mode is this particular command. So the cluster autoscaler -v is equal to 4 and cloud provider is equal to cluster API, because since the CSE created self-management cluster works with CAPVCD or cluster API VCD, it is important we provide the cloud provider over here as cluster API, because the cluster autoscaler actually works with the hyperscalers as well. So from our point of view, we need to provide the parameter as cluster API. Then next, and the next important parameter is the node group auto discovery. In this case, the namespace I have provided is TK8S-NS. And the reason why I've provided this namespace is because my worker node pool, which you just saw in a bit, is actually deployed in this namespace. And so what I want is my cluster autoscaler to discover the worker node pool, which has been deployed in this namespace. So as soon as this command is running and the pod is actually running, what it will try to do is it will try to look for where is the worker node pool. Is that worker node pool available in this namespace? Yes. Okay, great. So these are now the other parameters that you see over here is, what are these parameters is, some of these parameters are more around when to poll the pods so that it can scale up and scale down. So if there is a delay, we can add some of these parameters. The explanation of these parameters are actually there in the FAQ document, which I'll show you in a bit. So it depends on the customer how they would want to tweak the parameters based on their need of the cluster autoscaler for the cluster. And I'm actually running, I think I'm running the latest cluster autoscaler, and which is version 1.27.2, and this is the image. As you know, in the latest Kubernetes version, the registry has changed from the kubernetes.gcr to registry.kubernetes.io. So I've changed the cluster autoscaler to point to the latest image as well. So from here, what I would like to do is, let's go back into the presentation. What's the next step? If the cluster autoscaler is running, then the next step is to edit the machine deployment of the worker node via the API or the command line to include the annotations. And what are those annotations? Remember the min size and the max size that we have to specify in the worker node. So those are the annotations that we have to specify so that the cluster autoscaler can discover the worker node pool. So now let's go to the second step, which is, where is my machine deployment? So what I would do is I would say get MD minus A, and minus A parameter says, give me all of the machine deployments wherever they are deployed in whichever namespace in this cluster, right? So in this case, as you can see, it's loading, and it's loading. So as now you can see that the namespace where this worker node pool is deployed is TK8S-NS, and this is the namespace which I have specified in the deployment of Cluster Autoscaler as well, so that the Cluster Autoscaler can discover this node pool. Now to edit the machine deployment, it is very simple. We can just do kubectl edit MD. MD is the short form for machine deployment. And we can just say minus N TK8S, TK8S-NS. And as soon as I do the edit, what I have done already is, under annotations, this is a machine deployment. These are the two annotations that we want to provide. First is the node group min size, so that the cluster autoscaler won't scale down below this number. Yeah. And the second is the node group max size, such that the cluster autoscaler won't scale beyond this particular number. So these are the two annotations. Now, as soon as I add these annotations and I save this file, let's say, what's going to happen is the cluster autoscaler will discover the node pool. So you may ask the question that where do I see that the cluster autoscaler is able to discover the node pool? And that is exactly what I'm going to show you next. So let's look into the pods. Now the deployment, which has been deployed here, what it does is the deployment actually deploys a pod, and pod is an application of cluster autoscaler. So let's look into the pods, which has been deployed into the kube system namespace. All right. So sorry. So I missed the get. So kubectl get pods minus N kube system. And 1, 2, 3. Hopefully it should be coming soon. So
Briefing about labs.
Yeah. Oh no. Kubectl get PO minus N cube system. Let's try once more. Come on. Okay, awesome. So I got it. Maybe there was a network glitch. So here is the pod that you can see over here, which is running in the namespace. Now, what I would like to do is to tail the logs of this particular pod to see whether it is able to discover the min and the max node groups we have specified in the machine deployment of the worker node pool. So the next step is, I would say kubectl logs this particular pod and minus N cube system, and minus tail is equal to 100. So it is only going to tail the 100 lines, because since the autoscaler is running behind the scenes, you will see several different sorts of logs coming in over here. Now, the important thing to notice would be this particular log line. And as you can see in this log line, it says discovered node group, machine deployment namespace, which is TK8S-NS, and the worker node pool. And now here is what it recognizes. It recognizes the annotation which we have specified, the min group as the value is 1, and the max group, the value is 5, and the current replica, so the current worker node pool, the number of worker nodes in the pool which has been deployed is 1. So this is something very important. That is how Cluster Autoscaler actually discovers the node pool.
Yeah.
Okay, great. So what next? The next would be then what, let's go back into the slides. The next thing would be, let's deploy an application and let's deploy a horizontal pod autoscaler. What we would do is we will try to we will try to generate the traffic for this application so that the application can scale or the pods can scale. And during this process, what we will see is that few of the pods may go into a pending state due to insufficient resources. And then the cluster autoscaler will kick in and it will try to scale a new node. And then eventually we will see that the pod gets scheduled. Make sense? All right.
Yeah.
So let's do that. So what I've done is, let's go back to the browser, and in the browser, this is the documentation for the horizontal pod autoscaler coming directly from the Kubernetes blogs. Now, in this horizontal pod autoscaler, what you would see is the definition of the the definition of the horizontal pod autoscaler, what it is. How can you walk through? What are some of the prerequisites that you may require? So what I've done is basically I've taken this YAML file, and this YAML file is nothing but an Apache server. And what it does is it deploys a running Apache server in the in the cluster. So going back into my command line, what I've done is, and let's go back and look into the horizontal pod autoscaler. What I've done is, this is the deployment YAML file. It is an Apache server, and we are going to deploy this Apache server in our environment. And so let's take a look. I'll clear my screen. What I've done is I've created a namespace by the name of apps, and I've deployed this Apache name server on that namespace. So let's take a look. kubectl get pods -n apps, and you would see that there is an Apache server which is already running over here. So the next thing, if we go back into the presentation, is to configure the horizontal pod autoscaling for the application. Now, this is where when we were talking about the example of a critical application where it needs to scale up based on the traffic and scale down based on the traffic, this is where the horizontal pod autoscaler can be configured that, hey, if the CPU usage threshold is something like this, then please scale the number of pods to a particular number. And the way to do that would be, and let's take a look. Yeah, so here is a command which says kubectl autoscale deployment PHP Apache, as the deployment of this particular pod is PHP Apache. CPU percent is 50. So if the CPU threshold goes to 50%, then please scale the number of pods to a maximum of 5. And that is how it has been configured. Now, once you configure this, the next step would be to actually look into the horizontal pod autoscaler. And let's check the status of the horizontal pod autoscaler. The short form of that is HPA -n apps. And and as you can see over here, currently, since the deployment has been specified over here, the min number of pods is 1 and the max number of pods is 5, and the current replicas is 1, but there is no traffic. So no traffic.
Mm-hmm.
So the way I'm going to generate the traffic is, you can see that there is a load generator program, and this load generator program I'm going to run over here. The image, it is going to use a busybox image, and basically this is the command that gets fired, and this command will actually look after this particular IP and port. So you may ask, where is this IP? Is this the IP of this pod which is running over here? And the answer to that is yes. So how do I see that? If I say kubectl get service -n apps -o I think we will get that information. Exactly. So as you can see, 10.100.68.107.121 is actually the cluster IP of this particular pod which is running. So what I am going to basically just do is I'm going to run this load generator, and this load generator will generate traffic as you can see, it is successful and it is generating traffic. So now the next step for us would be to actually watch our traffic in the horizontal pod autoscaler. So we may have to wait for maybe like few seconds, but you will see that this particular CPU usage, which actually increase over a period of time. And as it increases, what will happen is the number of replica of that particular pod will increase. So which means that the number of pods will scale. So eventually, at some point of time during our demo, as you can see, it went up to 240%, and it is still the replica is 1. So what's going to happen is now the number of pods the replicas will increase. So it will scale the pods. And yeah, as you can see, it scaled to 4. So as a result, once the number of pods will scale, the traffic will stabilize, at some point of time. But this is the point where I'll likely come out of it. And I would like to see what is the status of all of the pods which is running in the apps namespace. So let's take a look. Okay, great. You can see over here that 4 of the pods of the Apache, PHP Apache is running fine, except 1, which goes in a pending state. So why is it in the pending state? So let's take a look. Kubectl describe pod PHP Apache -n apps. Okay. So let's see. All right. As here is the description that the nodes, 0 out of 2 nodes are available. Why? Because 1 insufficient CPU, 1 node had retained. So basically it does not have enough resources so that pod can be placed. And that's why Kube scheduler actually puts the pod in a pending state. So then what happens next? What happens next is the cluster autoscaler behind the scenes kicks in, and now it will try to scale into a new node. So how do we see that, that the cluster autoscaler actually kicks in? So let's take a look into the logs of the cluster autoscaler and try to observe if there is any changes over there. And if you remember, a similar log we saw previously, but what happened is the replicas at that point was 1, and the replica at this point of time is showing 2, which means that if we now go back to our browser and into our tenant, I am hoping that if we refresh, we are going to see a creation of new VM here.
That's obviously going to take a little bit longer than the node scaler, right?
Yeah, exactly. It will take at least, a couple of minutes, I hope.
Yeah.
So let's see. Oh yeah, awesome. So see, as we are, it's actually creating a new worker node pool. It is at the power off state, I believe so. And now the next step would be it will go into a partially powered on state, and then it will actually get powered on. And so I think at this point of time, what's going to happen is unless it gets powered on, then next step would be, let's go back and I'll try to show what are some of the steps that is going to happen is. Let me clear my console. The next step is when we do kubectl nodes, you would see that the VM, which gets into completely powered on state, that VM will be registered as the worker node pool over here. And you will initially see that the status of that VM is not ready, but in a minute or so, it will change it into ready state and the pods will be deployed.
And the role will change to worker node?
Yes.
Yeah.
Yeah. So let's see. It still says power off. Let me just refresh. I know there is a bit of lag in my lab, but hopefully, yeah, I think overall from creating the node to actually reflecting it into the Kubernetes cluster, it takes close to 2 to 3 minutes. So let's see. Yeah, so as you can see, it is now changing itself to partially powered on state. I hope so. Yeah. Okay.
It's getting there.
Yeah, it's getting there. So by the time that it is happening behind the scenes, Guy, any questions?
No, that's really cool. So it's good to understand that there is this flexibility to scale out the pods, and then there's the flexibility to scale out the worker nodes as well. One takes slightly longer than the other, so just plan your your scalability sizing according to needs. So basically, you really shouldn't be spinning up additional worker nodes unless you absolutely have to, right? I mean, because it's going to take a bit longer. You want to, it depends on the variation I expect in terms of the demand.
Yeah, it depends on exactly. Depends on the variation in terms of the demand. So one of the, when we were going through the slides, I was talking about the design considerations. Now, since this is a community-driven autoscaler, I would definitely like to point out the design consideration when it comes down to the UI. So we did mention that in the UI, we won't be, if the node pool is managed by the cluster autoscaler, then the current design consideration would be you should not manage the or try to resize the nodes through the UI. So let's say if I come here and then I say, hey, I want to resize my node pools. So that will, what it is going to do is that is going to interfere with the cluster autoscaler. So at present, that is something you should refrain from doing. So, and that it can be done from here, but that is something you should refrain from doing. In future, when actually this gets baked within the UI, then you will see few changes in the UI over here that you can either toggle or turn on the cluster autoscaler or turn off directly from the UI. But at present, that is something to consider.
Yeah.
Yeah.
That'd be very, very useful, that one.
Yeah, exactly. So let's go back into the UI and let's see into the command line, sorry, and let's see what's the current status of the nodes. Okay. So we can take a watch. So as you can see, the worker node pool VM is in the powered on state over here, and boom, this is in the ready state as well. So if I instead of doing a watch, if I just do kubectl get nodes, then the new node, which is I think it is C2PWP. Yeah, C2PWP is the new node. It is now in the ready state. Now let's take a look at the situation of all the pods. -n apps. Okay, it's currently in the pending state, but I am hopeful that in few minutes, we should see that the pod is running. If not minute, but few seconds for sure.
Sure.
And let's see if let's take a look at the load generator as well simultaneously, if that is working. Yeah, the load generator is still generating the load. So if we now take a look at what's the status of the HPA, kubectl get HPA -n apps, which is the horizontal pod autoscaler. So yeah, okay. So, the traffic has streamlined a bit now because the pod number of pods have scaled up and the replicas have scaled up. So let's take a look in the pods and still pending. So let's see, maybe a few more seconds.
That's weird because it's saying replicas 5, but the pods are saying pending.
Yeah, so the pod would say pending. Replicas is saying 5, and the pods, replica means that the pod has been deployed, but it doesn't mean that the pod is in the ready state. So it just shows the count of the number of the pods which has been deployed over here.
Oh, I see.
Yeah. So let's take a look why it is taking this much time for the pod to be. It's
there you go. Boom.
It's happening. It's happening. So, container is getting created, and since we are watching, we will definitely see it running.
Yeah, that's really cool, actually. Really, really nice facility for providing pretty, I mean, it's pretty simple to configure if you get the process right and you get all the files correct. I mean, it's a little bit fiddly at the moment, but as it gets kind of more UI based, it will be a lot easier to do.
Oh, yeah, yeah. I mean, the important thing would be to, at the moment, to play around with certain parameters based on what suits to whom, based on the application needs, and then deploy the application. But those are really simple. Honestly, going back into the slides, the only thing you have to really do is to deploy the cluster autoscaler with the right set of the parameters. Once you do, then you just have to edit the worker node pool to add those annotations of min and max. And these steps is really up to the application owners and the developers of how they are deploying the application, how they are configuring the horizontal pod autoscaling. But the idea is the cluster autoscaler will really help in scaling the nodes so as to deploy if there is any pending pods.
The service providers can deliver the Kubernetes cluster service with autoscaling already embedded in it, hand it over to the tenant and say, here you go. Oh, by the way, you know, one of the cool new features here is autoscaling.
Exactly. That is the goal. That is the end goal. That is the engineering team is right now driving. But as you can see right now, works.
Started, yeah.
Yep. All of them running.
So if you stop the load balancer, how long does it take to rip it all down?
Yeah, good question. Very good question. So I wanted to, glad that you asked me this question. So as you can see, I've just used Control C. Hopefully, it is going to terminate. So as you can see that it terminated the load generator. Now it takes 5 minutes after the load generator gets terminated for all of these pods to scale down. And then once the pods scale down to 1, what will happen is it takes around, it takes another 5 minutes for the cluster autoscaler to kick in to scale down the nodes. And that's how you can see. So those are configurable parameters, though. You can actually change the parameter for the cluster autoscaler to scale down and scale up. Now, in terms of scaling up, by default, the cluster autoscaler scan interval is 10 seconds. So it will keep looking at the machine deployments and the pods that hey, if there is a pending pod within 10 seconds, I want to scale a new node. So that's the scan interval in the cluster autoscaler, which can be changed. However, from the horizontal pod autoscaling, there are also configurable parameters that can be changed.
Awesome.
So that's a bit about the cluster autoscaling guys. So it was, I think we reached to a point where the native or the community-driven cluster autoscaler will work in CSE, TKG created self-managing cluster. That was the goal, and that is something I wanted to show in today's Feature Friday. Yeah,
it's brilliant. I'm super impressed with it. I think that's a really, because we saw the the scale cluster groups, I think it was called, within VCD, the Cloud Direct Scale groups, that's right.
Right.
Which was for kind of non-Kubernetes horizontal scale of VMs and VApps. And now we've got the same, like the Kubernetes cluster level and the Kubernetes node level. That's brilliant. It's full coverage.
No, so first of all, just want to thank you, Rohan, for a great presentation and demo. He has been championing a lot of field deployments, joint deployments with CIBG, the group I work in, with the MAMBG, the Tanzu team, right, on really getting successful wins in the market in different geos. So thanks, Rohan, for all your time and effort that you've been putting for many months. And just to wrap up, just a couple of things, call to action here, right? As we all know, the world of Kubernetes and the ecosystem around us have been growing very rapidly. I was reading the market report last year. The container service market grew like $2 billion, and it's forecasted to grow like close to $8 billion in the next several years. So what's interesting here is then, VMware and VCPP were very well positioned to own a good portion of this market if we play it right. So we have, we are bringing a lot of these innovations to our service provider industry, and we've been doing this from last couple of years, right? So we feel like we have a very broad-based portfolio of services and solutions that that our service providers, they can build, Kubernetes infrastructure as a service, also developer-ready cloud, based on their infrastructure as a service, within their data centers, and as they've been hosting the cloud services, using the robust VMware SDDC and the Cloud Director stack, overlaying that, with all the solutions and the services for the Kubernetes infrastructure service will definitely help them expand their business and grow their footprint, going into the, the container workloads running for their tenants and managing that centrally with a lot of the tons of services that's going to be integrated with the Cloud Director and the service provider stack. So overall, again, very compelling story, Guy and Rohan, and I think we're excited. We're putting a lot of effort into it, and we'll continue to have these sessions where we talk about some of the advanced capabilities around overall our app modernization portfolio. So thanks to both of you, and happy to be here.
Yeah, I think it's a great wrap up, Manish. I guess my only kind of call to action is, if you aren't looking at container services yet, the market is moving fast. We're already now in data science and AI ML, which I couldn't have seen about 3-4 years ago. That was we were still dealing with containers and the basics around containers. The CSE solution is very robust now. 4.0 was a substantial change in architecture. And as Manish has shown and talked about, there's a huge portfolio here, huge opportunity for you to address kind of new customers and customer demand. So get into that application space with them. Great portfolio of managed services that you can pull in on top of this by getting the right skills and resources in. So plenty of opportunity to grow your business. Rohan, before we go, where can people go to just find out more about the cluster autoscaling capability?
Yeah, so there is a GitHub. I can forward the link into the presentation. So there is a GitHub for Cluster Autoscaler. Plus, there is a white paper which is coming out. Manish.
Fantastic. All right. Well, we'll keep an eye out for that one. Rohan, thank you very much for today. You've talked a lot. You've done a demo. Really appreciate your time and effort in teaching us all about the new auto-scaling capability. And Manish, thanks a lot for coming on and talking about the portfolio and the way the portfolio is going under your product management, steering, and guidance. So cheers, guys. Thanks a lot.
Thanks.
Thank you.